So we're going to take a look at learning goal number 37 today. And 37 is going to be all about polynomials and taking a look at terms. So if we think back to what we did a little while back with terms of a polynomial and just understanding the terms, we had a couple different pieces that we needed to look at. So first things first, a term on a polynomial, I'm just going to write out a term right here, and we're going to do a little bit of definitions before we get into everything else. So let's do 3x squared. Okay, so this is going to be our term. And in this term, we have three different pieces. Number one, we have a coefficient. Okay, so a coefficient is this 3 term. It's the value that is in the front. And so I'm going to put that in there. I'm just going to quickly define these here. Try to do a little bit smaller so that it fits a little bit nicer. So we have our coefficient. Okay, so that's our piece there in the front. And I'm going to make sure that we spell it correctly because I can. Okay, so coefficient is the value that is in front of the variable. Okay, and that is the second piece that we have is our variable. Okay, so the letter portion is our variable. So our coefficient is that number that is in front. Okay, we are multiplying by that number, and that's going to be very important to look at as we keep going. But that is our coefficient. That's the piece that is in front. The letter that is a part of it is what's called our variable. We call it a variable because it changes depending on what value we give it. Okay, we give a value to this variable, and that will create an answer. But for right now, we're only worried about what does the term look like. And the last thing that is on there is our exponent, which is also equal to our degree. Okay, so there's our exponent on top as well. So our exponent is also equal to our degree. So this case here, this term has a degree of 2. Okay, it has a degree of 2. And so it's important that we remember that. It's important that we are aware of that degree and how it makes a difference in our term. So let's go through a little bit of review here. Let's remember that a polynomial is made up of one or more terms. Okay, one or more terms. And we're going to be taking a look at ones that are made up of lots of terms. We're going to be looking at ones that are made up of only like 2 or even 1 term as well. Now, the thing is that these terms are combined together with adding and subtracting to create an expression. These terms are often different. Okay, so every term has a different variable combination. It's important we remember that variable combination and how that makes a difference. If we think about algebra tiles, the size of the algebra tile determines the different types of terms. Okay, not the negative and positive, but the size. So we have like a small little one that represents a 1. We have like a rectangular one that represents an x. And then we have this large square which represents an x squared. And we could actually make these even bigger if we wanted, but for right now we're only going to deal with those as algebra tiles. Okay. These terms, as I mentioned, are added together to create a, I'm gonna say larger. Actually, I'm gonna go bigger. That's maybe not the best way to think about it. I'm gonna say bigger because it's a bigger value in total, but we could actually become a smaller if we're subtracting. When I say adding, we are adding because adding a negative is like subtracting. So we are in fact adding them together. Now, so that's just a reminder of a polynomial. Okay, so we can have a polynomial, and I'm just going to give a quick little example of a polynomial here again. This was a term. A polynomial could look something like this: 5x squared minus 3x plus 6. There's a trinomial. It's a 3-termed polynomial. Okay, so we have an x squared term, we have an x term, and we have a constant. And we call that a constant. So when terms, now we're going to focus right in on our terms here. When terms have an identical variable component, okay, when terms have identical variable components, okay, so remember that's going to depend on that variable. So in this case, it's x squared. Here it's an x. Here there's none. Okay, it's a constant. Then we consider these terms to be like. Okay, So then these terms are like, okay? They're not identical, depending on the coefficient, but they are like. They are similar in nature, okay? They're similar sized algebra tile, whether it's a little small square, whether it's the rectangle, or whether it's the large square, okay? They're similar in size. When we have like terms can be put together to simplify a polynomial or expression. And so in this lesson today, we're going to be taking a look at how do we combine like terms. So let's start with a very straightforward one that we should understand completely. 4 and 7. Okay, so when we say 4 plus 7, it's the same as saying we have a 4 and we have a 7 and we're putting them together. Okay, so that's a positive 4 and a positive 7. We thought of it as adding for years and years. Ever since you learned it back in grade 1, how to add numbers together. Okay, we always think of it as adding two numbers together. But in fact, what it is we have one positive and we have a second positive, and they're like, okay, they're common types of values, and so we can put them together, we can combine them. Okay, it's as though we have 4 students on one side of the class and 7 on the other side of the class, and really all we're saying is that we have 11 students. That's it. Okay, we're just breaking it apart in 2 separate groups. Here we have 2 separate groups, a 4 and a 7, and we're just going to combine them into one group. Okay, and so that group is 11. And I'm going to put an equal sign in there because we can consider it equal to 11 as well. But if actually, no, I'm not going to, because I don't want to consider this to be an equation. I'm just going to think of it as an expression. This expression has a 4 and a 7, and so this is now, we're going to combine it to 11. Okay, that's all it is. We're just combining things together. We're trying to simplify it. 4 plus 7 is slightly more complicated than the number 11. And so we're just combining those like terms because we're talking about the same thing. They're both constants. Okay, this polynomial, as I mentioned, has 2 constants, and these are considered like terms. Okay, so they are considered like terms because, again, they deal with the same thing. They're the same size block if we break them into algebra tiles. Okay, they are both constants, and they can be combined to create a simplified value or simplified term in this polynomial. Instead of having 2 constants, now we just have 1, and it still means the exact same thing. Okay, let's move into the next one here. Let's combine the like terms. Now, when I say combine the like terms, I'm actually being a little facetious here because there are no like terms here. Okay, we have a 4x and we have a 3. Now remember, if we're talking about this as algebra tiles, and I'm just going to quickly draw out a couple of tiles here. Okay, 4x would be not a straight line, we need rectangles. Okay, 4x would be like these rectangles here. And I'm going to do a terrible job of drawing it, but we can visualize these rectangles. Okay, we have 4 rectangles which represent that 4x. Okay, so the rectangles, and the 3 represents 3 little squares. Okay, they represent 3 little squares. Now, in fact, you might think, oh, maybe these 3 squares equal into one of these rectangles. We don't know that. We don't know how big those rectangles are. We give them an area, but we're not sure if it's actually the right area in relation to our squares. Okay, so it could be a really small rectangle. Like we could have, if x is a small number, then it's going to be a little rectangle like that. If x is a big number, it's going to be a big rectangle like that. But both of them equal to x because we don't know what x is. And that might sound a little bit weird to say that, but in fact, we don't know what x is, and so we don't know if it's a small x or big x, so we can't actually compare these little ones, which we know the size of, to an x term. We can't actually compare them because we don't have that. We don't know. Okay, we don't know where it is, and so we can't. We just yeah. We can't put them together at this point. see, there we go. Okay, I'm just going to try to move these a little bit out of the way here. There we go. Okay. Now, these terms are not like. Okay, so that's important that we understand here. These terms are not like. They have different sized rectangles. The x rectangle is going to be one size. The constant square is a different size. So we cannot combine them into one because they're not like. Okay, they're not like. Think of 3. Again, let's call that the number of students. And x represents the number of boxes. Okay, boxes and students are not the same. We can't actually group them together unless we want to think of it as things, but we want to think of it as individuals. Okay, so people and boxes. Here we have 4 boxes. Here we have 3 people. Okay, we can't combine them together. Okay, that just doesn't work. Okay, it doesn't work. Again, we don't know the size of the boxes. That's why we're calling it X. We don't know how big they are, but we know we have 4 of them. Okay, we can't combine the boxes and the people together because they're different things. Okay, so we can't do that. Now, like I said, these two terms are not alike. Okay, they're not alike because the variable combinations are not the same. Okay, and it's all based on that variable combination. Here we have a variable of x with a degree 1, and here we have no variable at all. So they are different. Therefore, this polynomial is as simplified as it can be. Okay? Again, like I've talked about, think of the terms as algebra tiles. Okay? If we think of it as algebra tiles, similar sized tiles can be added together. And that includes positives and negatives. We can put a negative and a positive together if they're the same size tiles. Okay? Different sizes cannot be added together. Okay? So they cannot be added together. So again, same sizes, we can put them together. Okay? People, we can put them all together because people are people. We're all people. We're all humans. Okay? But if we're trying to combine people and boxes, that's 2 very different things. And so we're not going to combine those together. Now, how do we add terms together which have a variable in them? To add terms together, we add the coefficients together, and we leave the variable exactly the way it is. We leave the variable exactly the way it is. Okay, again, think of it as a box. We don't know how big the box is. That could change, but there's a box. And every time we have an x, we have the same size box. Okay, so this polynomial here tells us that we have 5 boxes and we have another 4 boxes, and they're both positives. If we combine that all together, we have 9 total boxes. Okay, the size of the box didn't change because we're just grouping them now together. We had 5 on one side and 4 on the other side, and now we're going to put them all together. Okay, the size of the box doesn't change. All it is the number of boxes now that we're putting together. So we had 5 and we had 4, and we're putting them all together, and now we're going to have 9. So in this case here, when we're simplifying our polynomial, we have 9, or sorry, coming up with 9 already. 9 plus 4, or sorry, 5 plus 4, okay, is 9. And so this term is going to be the same as 9x. Okay, there are 9 x's now. We had 5 of them, we had 4 of them, and when we put that all together, we have 9 of them in total. Okay, so that's how we combine like terms. Again, they have to have the same variable combination. We're going to get into that a little later when we have different variable combinations. Okay, again, like this, we leave them, we don't even touch them. We only do the ones that have like terms. So let's just simplify each polynomial. Let's do a little bit of an example here. The first one here, we have 3 x's and we have negative 1x. Okay, we have negative 1x. Now there's 2 different ways that we can think of combining these together. So again, I'm going to go through and I'm just going to do a little bit with algebra tiles because I do have a couple questions with algebra tiles that I want you to do as well on the assignment, but we'll get into that on the next video here. So let's say, and I'm going to try to do as best I can here, we have 3 positive x's and we have 1 negative x. And they're actually separate. So I'm just going to pull them off the side. We have 3 positives and 1 negative. Okay. the negative and one of the positives are actually going to cancel out. So we're only going to be left with two positives. So we can actually like kind of stroke this one off and we can stroke this one off. Okay, and we're left with two positives, meaning that when we think of it that way, we have positive 2x. Okay, so we can think of it that way. Or we can also think of, okay, this is 3 plus negative 1, or which is exactly the same as like 3 minus 1. And this is the same as 2, and that gives us our 2x as well. Now, if I'm giving you algebra tiles or asking you to solve with algebra tiles, I'm going to want you to draw them out. Make sure you do. But if I'm not, all you need to do is show this expression here. Show that you're doing 3 minus 1 or 3 plus negative 1 and what your new coefficient is, and then give your final answer right here. And so I'm just going to put my answer right there with kind of right beside. So what we're doing is we're just simplifying these like terms together. Okay. Next one here. First things first, we want to take a look at, do we have the same variable combination? Okay, both of those terms have an x squared. That's it, just x squared, that's all. Because of that, that means that they are alike. It means that we can add them together. So we can do 6 plus 9, and 6 of something plus 9 of something is going to give us 15 of that total thing. And so we can simplify this expression or simplify these two, and we can write it as 15x squared. So our two terms together give us 15 of that total, so it's 15x squared. Okay, next one here. We have negative 2x and negative 4x. Think of it again, and I want to reiterate this over and over again. We have two terms. We have a negative 2x and we have a negative 4x, but they have the same variable. Okay, they both have an x variable. So for that reason, we can add them together, or we can put them together. If you want to think of putting them together more than adding, you can do that. Okay, but if we're adding them together, that's a negative 2 plus a negative 4. Okay, two negatives just combined together, okay, make a bigger negative. We're going to get negative 6 as our answer. Okay, so if we combine those two, a negative 2 and a negative 4, we get negative 6. And when we write this out in total, we have negative 6x. And there's going to be our final value. We have a negative 2 in front here. We have a negative 4 behind. We put them together and we have a total of negative 6. And x being our variable stays as our variable. This can also work if we have a combination of variables in a term. So you'll notice here that we have an x and we also have a y. So we have an x and a y combined. That means that it's x times y. So xy is going to be our variable combination. You'll notice that both cases here have the same variable combination. This is an xy, this is an xy. Here, there is a 1 in front that we don't see. We don't really think of writing it in, but it is there in front, and so we have to remember to put it in. So what we're going to have here is we're going to have 1 plus 3, and that's going to give us a total of 4 of them. So our final answer then is 4xy. At 4xy. So there's 4 groupings of x times y. Okay, we had 1 to start, 1 in the front, and we had 3 behind, and we add them together, and we get 4 of them. Now, I'd like you to start with question number 1 on the assignment. Question number 1 deals with just putting like terms together, and I give you just 2 like terms, and I ask you to put them together, a little bit of practice, and then move on to the next part.